All right, welcome back. Today, we're going to tackle what often feels like, the final boss of trig equations, the multiple angle problem. It looks super intimidating, I know, but as you're about to see, a simple two-part rule makes it surprisingly straightforward. So let's get started.
So check this out. On the left, we've got a classic trig equation, one most of us are pretty comfortable with. But on the right, well, that's its slightly scarier looking cousin. The only difference is that tiny number 2 tucked inside the sine function. But trust me, that one little number changes absolutely everything.
And that leads us to the central puzzle here. When you solve the equation on the left, you get two answers between 0 and 2 pi. But when you solve the one on the right, you get times 4. How is that possible? Where do those extra answers even come from? Well, the secret lies in this really simple two-part concept I like to call the widen and divide rule. It's all about understanding how that 2 completely changes the function's behavior. This is literally the key that unlocks all those extra solutions.
So here's the why. That 2 theta inside the sine function, it basically acts like a fast-forward button. It compresses the whole graph, causing the sine wave to complete 2 full cycles in the exact same space it used to complete just one. And it's pretty simple, right? Twice the cycles means twice the solutions.
Okay, before we go any further, let's get a key term down. That expression inside the function, whether it's 2 theta or 3 theta, or even something like theta divided by 2, we call that the inner argument. From here on out, our whole strategy is to solve for this entire block first.
This table really shows the widen part of our rule perfectly. You see, if the argument is 2 theta, we double our solving interval to go from 0 to 4 pi. If it's 3 theta, we triple it. And hey, notice that bottom row? When the argument is theta divided by 2, the rule just works in reverse. We actually shrink our interval.
So how do we put all this together into a process we can rely on? Well, it all builds into a simple 4-step method. That's going to work every single time, no matter what kind of multiple angle problem gets thrown at you. And here it is. This is your master key. First, we substitute that inner argument with a temporary variable, let's just call it u, and we scale our interval. Second, we solve the now simple equation for u. Third, we take our u answers and divide them to get back to theta. And finally, we just do a quick check to make sure our answers actually fit in the original interval. That's it. Theory is great and all, but let's see how this thing actually works in practice. We're going to walk through 3 different examples, starting basic and getting a bit more advanced, just to show you how powerful this 4-step method really is.
Okay, let's start with the exact problem from the beginning, solving sine of 2 theta equals 1/2. We're finally going to hunt down those 4 mysterious solutions.
Okay, step 1. We're going to let u equal 2 theta. Now, because our original interval for theta was from 0 to 2 pi, our new interval for u has to be twice as wide, so that's 0 to 4 pi. Now for step 2, we just solved the simple equation sine of u equals 1/2. But, and this is the important part, we have to find all the answers inside that bigger 4 pi interval. And here they are, our 4 solutions for u. As you can see, the first 2, pi over 6 and 5 pi over 6, those are the standard answers you get from the first cycle. The next 2 come from the second cycle. We find them by just adding 2 pi to our first answers, which gives us 13 pi over 6 and 17 pi over 6. Now for the divide part of our rule. We have our u values, but what we really want is theta. So we just divide every single one of those u solutions by 2. And that gives us our 4 final answers, all of which fall perfectly back into that original 0 to 2 pi interval. Feeling good? Let's up the ante a little bit. What happens if the inner argument is 3 theta? Well, the method is exactly the same, but now we should be on the lookout for even more solutions. That's right. With an argument of 3 theta, the cosine function completes 3 full cycles. So that means we widen our interval all the way out to 6 pi, and we end up finding a whopping 6 different solutions for theta. The process scales up perfectly. So what happens when the number is a fraction, like theta divided by 2? Does our method still hold up? You bet it does. This is what we call a half-angle problem, which basically means the function is stretched out instead of being compressed. Following our rule, an argument of theta over 2 means we have to solve on an interval that's half the size, just 0 to pi. And if you solve tangent of u equals 1 on that smaller interval, you only get one answer for u, which leads to just one final answer for theta. See?
The rule works both ways. Now, this method is super powerful, but there are a couple of common tripwires that can catch even the best students off guard. So let's go over them so you can avoid all that frustration. Okay, this is, without a doubt, the number one mistake: forgetting to widen the interval. The incorrect approach on the right shows exactly what happens if you solve on the normal 0 to 2 pi interval first. You miss half the answers. They're just gone. The correct way, shown there in green, is to widen the interval before you solve. And here's the second major pitfall. It is so tempting to try and solve for theta by dividing by 2 right away. But you cannot divide inside a trig function. It's just an illegal move. You have to treat that inner argument, that 2 theta, as a single, unbreakable unit until after you've taken the inverse sign. Okay, so we've mastered the math, but this all begs that classic question: when am I ever going to need to use this? Well, the answer, it turns out, is literally humming inside the walls of your house right now. This quote really gets right to the heart of it. For an electrical engineer, this isn't just some abstract math problem. It's an absolutely critical tool for keeping our power grid stable and safe. Here's why this stuff matters. The standard AC power in your home is a 60 hertz signal. We can just call that our base angle, theta. But imperfections in the system create these things called harmonics, basically interfering signals at double the frequency, or 2 theta, and triple the frequency, 3 theta. Engineers use this exact math to pinpoint the precise moments when these harmonics could cause dangerous voltage spikes. So, a single number can make a problem seem twice as complicated, but a simple method makes it totally manageable. Widen and divide isn't just about finding more answers. It's really about learning to see these hidden cycles and patterns that are all around us. So now I have to ask, what else could it help you uncover?